Alright, let's look at this problem. Okay, this is a problem of relative extremum problem, okay, or optimization problem here. So the question is given that that the figure, this is a cross sections of, there's a cylinder inscribed in a cylinder is inscribed in a cone, right? A cylinder is inscribed in a circular cone of height h. The cone you have height h, and the base of the cone, right, and the base radius h over 2 means that the radius of the cone, right, so it's h over 2. So the base of the cylinder lies on the base of the cone, means that the cylinder is inside the cone, right? It's inside the cone and it lies on the base of the cone. So I have to draw it out so that you can see what is the meaning of this question here. So it means that there is a cone, right? There is a cone. So inside the cone there is a cylinder, right? There is a cylinder. So there is a cylinder inside the cone where if you draw, so you can see. So this is the 3-dimension and 2-dimension. So as this cylinder has the height of y, right? This cylinder has a height of y, and the base radius here, the radius for the cylinder, this cylinder here, you will have x, right? You have x, and the base radius, the radius of the cone, right? The radius of the cone. The radius of the cone is given by h over 2. H over 2, half of the height here. So and the height of the cone, the height of the cone. So you have h, right? So that's the information that's given. So the height of the cone is h, and the radius of the cylinder is x, and y is the height, and the radius of the base of the cone is h over 2, the height divided by 2. Okay, so this is all the information given. Okay, so then later that they want you to find the relationship, means that they want you to show that y is h minus 2x. So means that they want to relate y to x, alright? Relate y to x. They have wanted to show that y equals to h minus with 2x, right? So according to this, so we have to use the diagram, right? We have to use the diagram here to see what is the relationship of y and x here. So as this, you can pause the video and you try to think. Okay, so now you can listen. So what is, so if I will see that this is a triangle, right? This is a triangle. So if I draw out here, so if I cutting out this thing, if I cutting out, okay, this cross section here, this will be a right angle triangle, right? It's a right angle triangle. So if I drawing out this right angle triangle, if I carefully observe that, I can see there is a triangle, right? That enlarged from this triangle, and this triangle is the enlargement, the image of this triangle here. So we can use the concept of scale factor here, or the similar triangle. All right, they share the same angle. So then then this is the value of y, right? And this is y, and this is h, right? This is h, and this is y. H and this is y. And this is x, right? As you know that this is x. So this is x, but how to find the length for this? As you know, this everything here is h over 2, right? H over 2 is the base of the radius of the base of the cylinder, right? H over 2. So to find the length for this, I have to take the longer one, the h over 2 minus with x, right? As you see that x plus with negative x, you're getting 0, you're getting h over 2, right, overall. So it means that this is x and this is h over 2 minus x here. So why I'm doing this? Because I can use the concept of enlargement. So where you learn during your Form 5, your modern maths, so where you can relate this variable by using the ratio, right, the ratio. So I can divide, I can saying that h over y, right? The triangle, the bigger triangle, h over y. This is the object and this is your image, right? So I take the length of image divided by the length of object. So I have h over y. So the scale factor is the same as you taking h over 2, h and h over 2, the larger triangle, right? The larger triangle, h over 2. Proportion is a proportion. H over y is the same as h over 2, right? H over 2 divided by h over 2 minus x, right? The ratio should be the same. So I try to rearrange. I am not sure, so I rearrange this. So as you're moving this here, you have h to the power of 2 over 2, right? H power, you cross multiply. So h power, okay, I just rewrite here so that h multiplied with h over 2 minus x, right? Then equals to h over 2 multiply y, right? H over 2 multiply y, h over 2 minus x, h, right? So then you can see that the h is a constant, h is a height, right? H is a height of the cone. It's a non-zero constant. It's a non-zero. So you can divide by h because it's non-zero, right? So you can divide because this is a constant. So you divide by h, not constant, it's changing also, but it's it's a cone, right? This is inscribed in the cone. The cylinder is changing, the cone not changing. So h is fixed, alright? According to the question, h is fixed. So you can divide both sides by h. So it means that h over 2 minus x is equals to y over 2, right? And you multiply everything with 2. I rewrite y over 2 equals to h over 2 minus x. And you are getting y to be multiplied by 2. Multiplied by 2, you have h minus with 2x. So you have get a relationship, right? Shown. You have get a relationship that relate y to x here. So then later you may using this relationship to solve the problems. Alright, so let's continue the question. So you can pause the video and see how to express the volume of the cylinder, right? The volume of cylinder in the fixed cone. The cone is fixed, but the cylinder can be changed, can be thin, can be long, can be fat, right? It's keep changing, but it's inside the cone. So then what is the volume of the cylinder? So you know that volume of the cylinder is pi r square h, right? Pi r square h here. So pi r, r will be x, right? Because this is the radius of the cone, right? Radius of the cylinder, and the height is y, right? The height is y. So pi r square y, x square y. So that's why you cannot have, if you want to differentiate in single variable, then you have two variables here, because y is changing, the height is changing, the x is changing, alright? So if the x is changing, definitely the y also will be changing, right? Because it's the cone, the cylinder is inscribed in the cone. So now the problem here is you already find the relationship between y and x, right? So you replace the y with x so that everything in terms of x. So v equals to pi x square and y is h minus 2x, right? H minus 2x. It's a polynomial if expanded. So it will be v equals to pi. So if you expanded this, you are getting hx to the power of 2, hx to the power of 2. The pi, I leave it outside, it's a constant. So hx to the power of 2 minus with hx to the power of 2 minus with 2x to the power of 3. Then this is the volume, right? The volume given here. So you must remember, h is a constant, it's the height of the cone, which is fixed. So, alright, so this is the volume in terms of x, right? Express the volume of the cylinder in terms of x. So, alright, let's look at the question later. Alright, for the following question that they said that find the volume of the cylinder. So the volume of the cylinder is maximum. Find the value of x in term of h. Okay, the value of x in term of h such that the volume of the cylinder is maximum. Repeat again, find the value of x, so such that the volume of the cylinder, right, this volume here, this volume is represent the volume of the cylinder is maximum here. So, and the value of x must in term of h. Alright, doesn't matter. So now we have this equation, right? We have this equation. So I'm going to differentiate first, right? You want to find maximum or minimum, you have to differentiate. So the maximum volume occur when the dv dx is 0, right? So differentiate, pi is a constant. So differentiate, you have 2hx, right? 2hx minus with 3 to 6x to the power of 2. Yes, 6x to the power of 2. So now you're going to, if you want, you can differentiate if it further, because later you will use this for second derivative test. So then you differentiate again, and you have 2h minus with 12x, right? This is we using later for second derivative test to verify that the point is the value of x is a maximum value, the maximum point or minimum point, right? So, alright, now we're going to take the dv dx equate to 0. So the dv dx will equate to 0 because we want to find the stationary point, the extremum point, the relative extremum point. So we're taking it equals to 0, which will be pi, this whole thing here, equate to 0, 2hx minus with 6x squared equate to 0, right? So this is what I do now. So I divide by pi, pi is a constant, divide by pi, so you are getting 2hx minus 6x to the power of 2 equates to 0. And x, you can factorize the x. I factorize 2x and I have h minus with 3x equate to 0. Right? So you see that 2hx, 2, 3, 6x to the power of 2. So 2x equate to 0 and h minus 3x equate to 0. Right? Quadratic, this 2 will be 0 if either this or this 0. So you're getting x is 0. And you're getting here to be x to be h over 3. Right? x0 is very impossible. Why? Why you want to study something that the cylinder, the x here got 0? Right? If x is 0, there are no cylinder, right? Logically, if x is 0, this is minimum. It's minimum. Means that the cylinder is minimum when the x is 0. Means there are no cylinder, right? There are no cylinder inside the cone. x0 means the radius 0. Right? The dimension is 0, so it's not going to form a cylinder also. So it means that this you're going to reject. Right? This is not the one that you want to study. But you know this will be a minimum. So then, because they want to find the maximum volume, right? Maximum volume of the cylinder is happen when x is h equals to 3. But you have to verify whether this x is really give a maximum or not. Okay, you have to verify, even though you already know that this sure will be. So it's a procedure for you to verify, right? So let's go for this test here. So the second derivative test, right? The second derivative test to further prove that it's true, right? Derivative test. So then you have dv2 dx2 when x is h over 3, right? X in term of h. We want to verify, is it true or not? So then we have to pi, 2h is a constant, 12 times with x is h over 3. 3, 4, 12. So you have pi 2h minus with 4h, which is a negative number. 2h minus 4h, you have negative 2 pi h, right? 2 negative 2h, negative 2 pi h. And pi is a positive number, height is a positive number, and this will be a negative number. So shows that this will give you the maximum volume, right? This x equals to h over 3 will give you the maximum volume of the cylinder. Means that maximum value of the cylinder happen when the x is 1/3 of the height of the cone, right? So therefore, this is the x here, that in term of h. So that's the answer. So hope you understand the whole problem and carry out the algorithm to finding the maximum and minimum value.